Hello. So in this class, we'll do calculus, formal definition of limit or epsilon-delta proof. So in the previous class, we did the concept and some basic problems. Today, I'll just repeat a concept for in brief, and we'll try to do more challenging problem. So formal definition of limit says that if fx is a function like this, and it is defined on an interval that contains x is equal to a. Here, except possibly at x is equal to a. Because when we are studying limit, we are not worried about what happens at the point. We are worried about what happens around the point. So that contains x is equal to a, except possibly at a. Then we can say that limit x tends to a, fx is L. If for every epsilon greater than 0, there is some delta greater than 0 such that fx minus L is less than epsilon, and we can see here in fx lies between fx plus epsilon and L plus epsilon and L minus epsilon. There is some delta greater than 0 here. These distances are delta such that x minus a means x is between a minus delta and a plus delta. So I've explained this in detail in the last video, and we have done some basic problems. Now let's do one challenging problem now. So this is the question given to us, and we have to epsilon greater than 0 is given, and we have to find delta, which depends on the epsilon using epsilon delta proof. So epsilon delta greater than 0 is given, and we have to find delta greater than 0, which will depends on epsilon, so that we'll use this definition fx minus L. L is negative 1 by 4 that we will substitute here. So such that absolute value of fx minus L is less than epsilon, where x minus a, where a here is negative 6. So x minus a is less than delta. So let's substitute the value of fx and simplify. So now we've substituted the value of fx here, which is x plus 4 by 2 minus x plus 1 by 4. And taking the LCM, we'll just simplify this. So here we get is uh, 3x plus 18 over 4, 2 minus x is less than epsilon. Now let's simplify this. So on simplifying, we see that 3x plus 18, so we can factor 3 out, we can factor 4 out, and it was like absolute value of a over b, we can write it as absolute value of a and over absolute value of b. And also 2 minus x, for simplicity, we can write it as x minus 2. Now, when we compare this and we compare this value 3 by 4 x plus 6 over x minus 2 and this x absolute value of x plus 6 less than delta to get the estimate of delta in terms of epsilon. We see that there is an extra term absolute value of x minus 2 which we need to eliminate. So we can assume delta less than 1 because definitely it is greater than 0, but it is very, very small. And we see that as x is approaching negative 6, x is very close to negative 6. And we can say that x plus absolute value of x plus 6 or delta, we can say it is less than 1. Now let's open up the absolute values. So as we open up the absolute value, we get here negative 1 is less than x plus 6 and x plus 6 is less than positive 1. Now we'll subtract 6 from all sides of inequality. So we get is x is greater than negative 7 and less than negative 5. But we have to eliminate x minus 2. So we have to get this x into change that we get x minus 2. So let's subtract negative 2 from all the sides. We have to do the comparison in this form. So our aim is to get a comparison in terms of absolute value of x minus 2. Now we subtract plus 2 from all sides so that we get x minus 2 in the, we get the inequality in form of x minus 2. Okay. So here we know that negative 7 is less than 0. So if negative 7 is less than 0 and we know that x minus 2 is less than negative 7, so x minus 2 will be also less than 0. So provided x plus 6 is less than 1, which we have assumed, then x minus 2, which is less than 0, so absolute value of x minus 2 can be written as negative x minus 2 because it is less than 0. So now this inequality is given here. We multiply this inequality with negative sign. So it gives us this inequality. 7 is less than negative times x minus 2 is less than 9. But we saw that absolute value of x minus 2 is less than negative x minus 2. So we can substitute now instead of negative x times x minus 2, we can substitute the absolute value of x minus 2. So provided x plus 6, absolute value of x plus 6 is less than 1, which we have assumed, instead of the negative times x minus 2 less than 9, we can substitute absolute value of x minus 2 less than 9 or greater than 7. Now we have got this equation. We know that if any value like k is less than 9, then we can write that 1 over k is greater than 1 over 9. Okay. So what we are interested here is, because we are interested here is on 1 over x minus 2. We need to eliminate that. So we want to bring this in the denominator. So we can write like this. We see that here 7 is here. 7 was less than x minus absolute value of x minus 2. So 1 over 7 would be greater than 1 over absolute value of x minus 2. Now this we will substitute in the equation we used here. Okay, in this equation we can put it here and get our values. So we see that 1 over x, sorry. So we see that 3 over 4 x plus 6 here, x minus 2 is less than epsilon. And because this value 1 over x minus 2 is less than 1 by 7. So if we replace it, it will be still less than epsilon. So instead of 1 over x minus 2, we'll replace 1 by 7. Now let's simplify this. So when we simplify here, we find that x plus 6 is less than 28 by 3 epsilon, whereas x plus 6 is less than delta also. So we can say that delta is equal to 28 by 3 epsilon. But we also assumed that delta is less than 1. So as we chose delta less than 1, and we also got a delta can equal to 28 by 3 epsilon. So we will choose delta, the minimum of both of these values. So hope it is clear to you now, and please let me know if you have any difficulty, and we can do more complex problems in the next class. Thank you.